Hi, everyone. Thanks for showing up here to this medium iron panel. You have the world's experts on how to deal with medium iron right here. Now, this panel has never been assembled with such an amount of expertise here. Now, I'm not kidding. I mean, this is an incredible panel, and you guys are very, very lucky. And again, thanks for showing up here. I'd like to make this, I'm the moderator here. My name is Mike Chaponas, and I was involved some with the PDP-1, a little bit with the 1401. And each of these folks here were on the restoration team and or are currently part of the docent force that shows these machines to the public and how awesome they really are. So I'd like to make this interactive, though, in that I have a list of questions. They're really sort of backup questions and things to get things started. But I'd like to make this audience-driven because, after all, you guys are going to think of questions that I am not able to think of. So please go right ahead, break in. We'll deal with it and we'll handle them because you've got the leading experts here. I'd like to just quickly go through each of the panel members. Do we have a microphone on this side? Okay. And just have each of them tell us a little bit about themselves and their role in here. We've mixed up the PDP-1 and 1401 folks because I think that this is really a museum effort. It's really something special that the Computer History Museum does, and where each of us are really proud to be a part of it. So please, if we would, from this end, tell us a little bit about who you are, a sentence or two, and why you thought it was interesting to try to do restorations. What machine, by the way, you also worked on.
Okay, thanks, Mike. My name's Joe Frederick. I'm a double E, actually, among all these software people. And I worked on the PDP-1 restoration and some other stuff before that. Why is it important? Well, I think it's more cool to do restorations than to just look at the artifacts. And it's also really cool for the public at large to be able to see some of these artifacts actually running and then to be able to talk about them and kind of educate people about what technology was like in what I call the Dark Ages.
My name's Ken Sumrall. I am computer engineer by training in college, but I pretty much did software for the rest of my career and working. But I've always had an interest in hardware and old computers. I collected a bunch of mini computers. And then I had some friends who were on the PDP-1 restoration team, and I wasn't on it originally, but they told me they thought Space War was going to run this coming up night, and I said, oh, can I come watch? Because I really like the game Space War. And I came and watched, and it didn't run that night. As a matter of fact, we blew circuit breakers. But I got involved in the team and started fixing stuff and been on the team ever since and love it.
I'm Ed Phelan. I'm representing the General Electric Computer Department, long defunct. The 1401 crew has kindly let me join them, and I've been having a good time ever since. Thank you.
Hi, I'm Lyle Bickley. My background is electrical engineering, but I actually ended up doing software as much as I did electronics, which I was always glad to have known hardware as well as software, so that was cool. I joined the PDP-1 team because I thought it was just absolutely a fabulous machine. It was a transitional machine. It was the first mini computer, the first computer that Digital Equipment Corporation made, so man, who wouldn't join that team?
Garner. I'm been the lead of the 1401 project since 2007. It's been a fantastic experience in, is it loud enough? Can people hear me? All righty. Even louder? Okay, how's that? I couldn't even reach the panel of 1401 when I was born. When the project started, I was actually thinking of working on the PDP-1 project, and Mike said, is anyone interested in leading a project to restore the 1401, which was announced in 1959? And I raised my right hand and said, because I just joined IBM, and I said, sure, I'll do that. Then I raised my left hand and said, what on earth is a 1401? So it's been a great learning experience.
Hi, I'm Carl Claunch, and about 3 years ago, Robert Garner started swinging a pocket watch in front of me. And before I knew it, I had joined the 1401 team. And it's a blast working on it. It's also great to be able to decode puzzles, figure out what people meant back in 1957 that bears no resemblance to the way we talk about hardware today. So, a tremendously enjoyable project.
And I am Mark Verdiel. I'm kind of a latecomer to the team also a few years ago. I just came here for a visit, and so it was incredible to revive a computer like this. And I told them that I'm a former Intel fellow, but on the side I build R2D2s in my basement. And they say, oh, fine, you're hired. And no, since then I've caught the bug because we have restored other machine. We have our Alto back there. And I think it's a delight. It's a lot of fun to deep dive into those computers at the transistor level, and you learn tons of things. So I join it. And also you need new people to come in to learn from the old folks. So it's been a delight to work on the machine.
Hi, I'm Pat Booter, network and software engineering by background. I came to the 1401 team, not in the restoration part, but in the docent part when we started doing scheduled demos for the machine about 3.5 years ago. And it's a real treat to take these guys' handiwork and tell the public about it. So,
I'm Steve Russell. I used the PDP-1 when it was new. And so I got called by the PDP-1 restoration team. And usually what I did was answer email and say, oh yeah, we used to have that problem. But maybe it helped. And I helped with the demonstrations, and I talk a lot.
Steve is, as usual, not really telling the full story. It turns out that there's this small program that's called Space War that the PDP-1 runs, and Steve is a principal author of that piece of software, and so we believe that he is continuing to provide software maintenance probably for the longest time in history. I'm not really sure. We might have a record there, Steve, but anyway, we still have support, which is quite impressive. I wanted to say just a little bit about putting this thing in perspective. I think of the PDP-1 and the 1401 as sort of sister machines, but these wouldn't even be here if it weren't for a fellow named Dave Babcock. Dave Babcock was very interested in his first computer, which happened to be an IBM 1620. That particular machine got a team around it. It was the first, as far as I'm aware, real restorer that the CHM was involved in. However, that machine, although there was a lot of work put into it, and that's where I learned a little bit about this restoration process. Joe was on the team, and some of the others here. That machine just wasn't, I guess, as easy to demonstrate as the PDP-1. So, or for that matter, something as awesome as the 1401. So although that machine isn't currently available to show folks, just want to let you know that it was Dave and those pioneers there who sort of set the stage for doing restorations there at the Computer History Museum. Now, I'd like to briefly talk about the genesis of both of these projects, and for that I'm going to ask Joe Frederick here, who's the hardware lead on the PDP-1, and also Robert Garner in a minute to briefly talk about how these projects came about.
Okay, thanks, Mike. Well, to the best of my recollection, subject to correction by these gentlemen, Mike and myself and Eric Smith, who is in Washington, I guess, right? Washington State. Colorado, thank you. You know, we kind of had this sort of exposure on the 1620 project a little bit and thought that it would be really cool to do the PDP-1. And so we got our heads together and we drafted a proposal, a restoration proposal to the museum. Took a couple of iterations and we submitted it. And they agreed to let us work with the artifact. And so that was kind of the beginning of it. Steve was one of the, in our proposal, let me put it that way, we had the three of us named, including Steve, which we had found out that his significant contribution with regard to Space Wars. And so that was kind of the core team. And then I think as soon as we got physically organized. Other people had heard about us and the program, and we got a number of other volunteers, which are listed on the chart there.
Well, thanks, Joe. Thank you. And Robert, I know you mentioned a little bit about how you got hoodwinked, volunteered for this position, but maybe you could just give a little bit about the initial genesis here and how it went.
Yeah, the 1401 project started when, like I mentioned, when Mike, I guess I was part of the PDP-1 project for a few short weeks. When Mike indicated the system was available in the German eBay, luckily no one thought they needed it for their living room. And so we contacted the owner of the system in Germany, and I was working with some people. I had joined IBM, so I was working with the team in Mainz, and they went and checked it out. And it was kind of rusty, but sight unseen, we decided to go ahead and purchase it, and IBM paid for the transportation here. The first challenge I had was, how on earth do you get a 50-year-old computer full of mechanical components to work again? Because, I certainly wasn't born with that knowledge. So I was told there was a group called the IBM San Jose Retirement Club here. And so I put an ad in the IBM retirement newsletter that said 1401 needs help. And I was shocked. A week later, about 20 retired IBMers came, and they said, well, we're here to help. And they were a little uncertain about the museum. No one's here from the museum. I'll never forget, one of them said to a museum curator that everything the museum had was junk because none of it worked. It was kind of a defining moment. So certainly the intention was to bring the machine back to life, to create what I now view as a time machine experience. When people go in that room, they truly do feel like it's 50 years ago. And our hope and our desire is that people will lose track of what time means and can start thinking about what computing will be like 50 years from now, to give that kind of authentic experience. And the team has just been with it since 2004, just committed. The system, each system has 500,000 components. We have 2 systems to keep it running. So it's just been a great feeling of commitment. And I can give a whole 2-hour talk about the 1401, but I'll just start with that.
Yeah, thank you, Robert. This is a tremendously large project with lots and lots of folks and lots of effort over a lot of time, with a tremendous, I think, result. And yet, we're talking about restorations here. We're not talking about getting the computers running and throwing out all the crappy parts and putting in brand new ones or whatever. We're talking about some sort of artifact here that needs to be treated like an artifact. And I'd like to address this question to Lyle. Lyle has quite a bit of experience in this area, has a large collection of his own, has been involved in these projects and many more. And Lyle, I wonder if you could please give us some insight into how you treat the restorations of artifacts differently than you might fixing an old radio or something like that.
Yeah, there's a big difference in how you treat an artifact. First of all, you can do no harm to an artifact. You don't want to do something that will destroy it. One of the most important things that we did when we first did the PDP-1 project was to lay out a restoration plan. So it wasn't a matter of let's turn it on and see what happens. That's the last thing we would want to do, because we could destroy the artifact. The second thing was that the museum had said that they wanted to ensure that every component we replaced was of the same vintage as the component that we were replacing, so that we had to maintain the artifact quality and maintain that. It wasn't a matter of just getting the machine running, in other words. It was a matter of getting it running with parts that were of the same vintage. And we managed to do that with very rare exception in the machine. The second thing that we did was every part that we removed from the machine was placed in a plastic bag and tagged as to where we had replaced it, both in terms of the module that we replaced it in, as well as the location of that module within the machine. The idea being that you can always you could theoretically put the machine back in the same condition it was when you received it. And that's critical if you want something to be maintained as a museum quality artifact. So all of these things extended the time of the restoration. We could have done it a lot faster if it was just like, make it work, guys. But it took longer because we had to maintain its quality as an artifact.
I'd also like to ask Joe a little bit about this. I wondered, what was your estimate of how long it would take to do this PDP restore, and how long did it really take?
Well, of course, optimistically, we thought 9 months, and that was, well, there's some logic behind that, and that was because we knew that the PDP-1, this particular item, had been running at the Computer History Museum back in Boston, and that was, maybe 12, 15 years prior. So we thought there was a pretty good probability that, we could bring it back to life. But it took about 2.5 years.
I'd like Ken to follow up on this some, because what sort of difficulties did you find with this particular machine, electrically, mechanically, or anything in between?
The electrical stuff came together pretty quick, but we at one point Mike started joking it wasn't the PDP-1 restoration project, it was a PDP-1 peripheral restoration project. The peripherals are somewhat mechanical, and therefore they're more prone to breakage. The console typewriter in particular was known to be finicky even back in the 60s, and Lyle and I and Mike too, spent way much more time on that than we thought anyone should ever have to. Also, we had issues with rotting belts that weren't made anymore. We had to get them custom made for the paper tape punch. And some high voltage, some of the current drivers for the CRT were also difficult to get going and maintain.
Okay, thanks very much. Ed, I had a question for you. Ed, you've been, you're representing GE, but after all, I think GE did make a compatible 1401 processor at some point, so you're actually really on the 1401 team, so we'll accept you. But you did a heck of a lot of work to document, photograph, organize, and otherwise make it possible for others to really appreciate and to contribute to the effort. Could you talk a little bit about that over such a long time, too? That took quite a bit of effort, and I think you ought to be recognized for it.
First, I'd like to talk a little about peripherals. I'm sorry about that. He said he's brought a big stick, but I don't see the stick, so I'm going to wander a little. Oh, okay, sorry. Anyway, I did work for General Electric Computer Department, and we had peripherals. They were terrible. We think we had the world's worst, thank you, card reader. It was made in England, and we had the Analex drum printer. Any dispersion was vertical, that's bad. We had tapes made by Ampex that were instrument tapes, and we were trying to run them as data processing things, beating on them 8-10 hours a day. So I wanted to see how it was done right, and that's in part why I wanted so desperately to see the 1401 equipment, which has the world's most beautiful active card reader, punches, the wonderful printer, and the mag tapes you'll die for. I forgot what I'm supposed to talk about.
Well, consider it a success, because I didn't get the stick out. So, again, audience, please, if you have any specific questions, please bring them up. We'd love to field them. And if not, I'll keep going with the stuff that I've been planning on grilling these people with for a long time.
I think I remember about documentation.
It was about documentation, yeah.
Okay, I like to do websites because my memory is so terrible that if I don't get it written down, it's gone. And so we have the schematics on the website. We have the logs from the early days, who came, what we were doing, the struggles we had when we had first light something worked. And so we have a very complete documentation available on the web, and I think I've overstayed my welcome.
No, I don't think so at all, Ed. You've done a tremendous service and really appreciate it. Please.
Yeah, I have to say that if you send an email that has anything to do with the 1401 or any other technology matter, within hours it's up on his website. Somehow he sucks it on the website and publishes it, so it's a tremendous resource.
And it really, yeah, without your work on the website, I mean, you think you can start a blog and people will contribute, everyone, but it doesn't happen. You need to have someone who has the discipline to send me what you did, take pictures, document, and Ed has been that disciplinary person. I don't know where you got it from, but...
So, Mark, I have a question. So, when you were working on this, what sort of things did seemed sort of really unusual and special to you, and why is it so magic that you spend time doing restorations on these old, ancient, obsolete, machines?
Well, it's not any machine, right? It's a multi-million-dollar machine that was extremely well engineered. So it's a marvel of engineering. It has a lot of mechanical parts, and I love mechanical things. And some of the most unusual things were mechanical, right? So tape drive fails, and there's a part in there. The carbon brush is a good example. We can't find a new one, and it's not a brush. It's more like a rod of carbon. What do we do? Well, hey guys, I have a lathe, and that's what I use to make my R2D2. Let me make one. And so we made. You start up the lathe, and you fix your tape drive, right? The other thing that surprised me is when we had errors in instructions, which come out regularly.
I'm pretty sure this machine wasn't built by Intel, right? And it doesn't have an Intel floating point processor or anything in it, right? What do you mean errors and instructions? What does it even mean?
Transistor level, right?
So you're saying that there were some instructions where you'd say do this and it did something else?
So it means that we run a program, there's an error, and there's an instruction that doesn't work, it doesn't add correctly, it doesn't do a branch. And usually it's a single transistor, one of 20,000 in the machine somewhere. And my modern engineering way, I was going to reach for the logic analyzer, and then the Ron Williams, who used to debug those machines, looks at me, logic analyzer? What do you use that for? No, you take a scope and say, oh, okay, so you scope, what do you sync it on? Well, those outputs here in the front panels, they are all the things for the scope. There is one that comes out for every cycle in the computer. So they scoping out a 20,000 transistor machine with was kind of a new concept to me. It works very well.
Yeah.
We always find a fault.
Yeah, that is some of the magic of these older machines, and yet I think that everyone does this in order to eventually help the general public understand sort of the magic of these older machines, and to that end, you've got to have software. So I'd like to ask Steve Russell to talk a little bit about the software environment that we have on the PDP-1 and why without software we're really just a bunch of doorstops, big ones though.
There is a good simulator for the PDP-1, there was a good simulator for the PDP-1, SimH, which allowed debugging software when the machine wasn't running. And an early dilemma that we found was Peter Sampson found a bunch of music tapes that would play music on the PDP-1, but they were the data tapes. And much searching did not reveal the program. And so Peter took the files, looked at them, deduced what format he had used 40 years ago, and rewrote the music player program, debugged it mostly on SimH, and brought it in, ran it on the real PDP-1, and with a minor problem, it worked, which is pretty heroic programming. But it also says that SimH works well enough.
So,
And a lot of the other software, we just had copies that were good and just used them.
yeah, you're referring here to Peter Sampson, who's away. Otherwise, I'm sure he'd love to be here. Peter is the author of this music program that gets played when we demonstrate the PDP-1, which will happen right after this at 2:30. Please check it out. So what you're saying is that the software simulation environments were really good enough to be able to do this development, even for a timing-sensitive kind of task.
Well, one of the problems with most simulators, including SimH, is that they're too fast. The PDP-1 is really slow, and for some things like getting the music sounds right, you need a simulator that runs in real time, and there isn't one that's good enough for music. There is one that's pretty good for Space War.
So I'd like to ask Pat a question about being a docent on such an impressive machine. Just what sort of things do you see in the eyes of the visitors? What really delights them? What really seems to excite them? The 1401 has all that iron. It's got card readers and punches and tape drives, and oh my God! I mean, you're definitely engulfed in sort of sensory overload there, and it's just amazing and wonderful. And the PDP-1 is a bit more laid back, I guess, although Space Wars can be quite exciting. But Pat, please tell us about what you find about the visitors here and how they really are impacted by this machine.
So demonstrating the machine is a real pleasure, but what the biggest challenge we probably have as demonstrators is to relate this machine from 1960 to people that come in today, particularly younger people. They're used to doing computers their entire life. They're used to touching a computer directly, having a screen, keyboard, those kind of things. None of that, of course, is on the 1401. It's a card system. You have to go to a key punch to do your data entry and then take the cards over. That's one thing that they're always surprised at. One of the biggest, they enjoy watching the printer, and all the mechanical things happening, a lot of good noise. We always ask them at the beginning of the demo, what do your senses tell you about this room? So things like smell, size of the stuff, the size of it, noise, everything like that. Our biggest challenge is doing that relation. How do you relate what you do today versus what we have there? And probably one of the biggest hits of all is when we take out one of the parallel cables that are underneath the floor. We start by saying, well, how do you hook your printer to your PC today? Ask them, they say USB cable. And then we say, well, here's the cable we use here. And you lift up this big honking cable. And pretty much the reaction, most of the time, is laughter. Sometimes it's the words, oh my God, stuff like that. So the reaction of the people is certainly a real rewarding part of it.
Thank you. Now the PDP-1's a different experience, but Lyle and Ken are two of the prime demonstrators of that machine, and I'd like you to give us both of your opinions of what it's like to do that kind of thing, and what is it about the PDP-1 that seems to excite people?
Well, folks generally come in to look at the PDP-1, and one of the questions I always ask them is like, why did you come in? Did you come into the room because it had the number 1 associated with it? 1 must mean the first or the best or something, or because it's called a PDP. And I always get funny reactions, of course, from people. They have no idea what PDP means. Most of them think that 1 must mean that it's probably the first of something. So we usually start with that. And people are impressed that it's the first mini computer. And they look at it and they go, and they laugh because, it's a big computer, but it's a mini computer. And then we have to talk about what it's mini compared to, mainframes that were, filled a room. And so it's always this comparison, very similar to what the 1401 folks deal with, which is trying to make this comparison between the older machines, mainframes that took a room, to a mini computer that was in, a few racks, to today's machines, which are personal computers. And then we talk about why the PDP-1 is a personal computer, because of the fact that one person can run it. One operator can run the machine and run the software and run the programs. And I think that one of the things that it makes people very excited about the PDP-1, and they always love, and the thing that we actually, when we did the project, we had one goal in mind, and that's to run Steve Russell's Space War. You know, and when we put Space War up, people get excited and they want to play the game. And to think that they're playing a 1962 piece of software on a 1962 computer, they like that and they get excited. And I think one of the most satisfying things to us is a lot of times when we finish up the demo, the whole crowd just erupts and gives us a big hand. And that's a great feeling, because then we know that we've gotten across what a great machine it is and what a transitional machine it was and how important it was in the area of computing. So it's a pretty exciting experience to demo the PDP-1.
A lot of what Lyle said I agree with. I don't disagree with any of it, but I want to add that also Peter Sampson's music program gets quite a response from the crowd. We just sort of talk about how the PDP-1 is limited in CPU resources and how hard it is to actually generate music on the fly. And then when we hit the start button and it starts playing in 4-part harmony and it sounds good, they're quite surprised. And there's always, people in the audience, their eyes get big and a smile appears on their face, and they're quite impressed by what Peter was able to make the machine do back then.
So, go ahead.
I wanted to relate an anecdote relating to how do people react to the 1401. And that's one summer, I think, we had some students from San Jose State.
San Jose State?
Yeah, and I think that's it. And they were, we taught them how to program the 1401. And there was this young lady there, and then after a day of labor, she punched a stack of cards. Then she puts the stack of cards in the reader, and up it goes, make all that noise, and out of the printer comes something which is the right answer. And she literally jumped up in the air, made a pirouette, because the computer got the right answer. I was like, whoa, you don't do that when you vanquish a bug in your PC. that's the laughter of having that big monster just move. That was exceptional.
Yeah, I mean, did you have something to say about that, Steve? Okay, so yeah, the 1401 is even slower than. Yes, go right ahead. Yeah. Yeah, let me repeat your question, and that is on the 1401 side, were there some programs that were been around a while and were you able to run those old programs, and what's the story about software and old programs there? Robert?
Yeah, we have a software team on the project, by the way, so I'd like to invite you to join. It's a rather unfortunate side effect of history that companies even as large as IBM did not save their original software. Now, much of the 1401 software was written by random companies, right? The business companies, the banks and whatnot, and a lot of them didn't save their software. We were blessed when we got the system from Connecticut that it came with the Fortran compiler and the COBOL compiler. We haven't been able to download either yet into the machine. The Fortran compiler is very famous. It's 63 passes, assembles in place in 8K of memory. And actually, we were able to get contact with the original designers of the Fortran compiler. We've had to write new programs for our demos. So Big Print, Ed, didn't you write Big Print? Ed, didn't you write Big Print? Didn't you write Big Print? Yeah, so the printing program was started here by Ed. So our GE guy wrote an autocoder program for 1401. The Power of Two program you see out there fits on a single card deck. Well, I'm exaggerating a bit. The one we run there prints out the answer in decimal, but I challenge anyone to write a similar program that runs on a PC or a RISC machine that can print a table of all the powers of 2 in less than 10 instructions. We know that all current machines will execute millions of instructions to do the same thing. So it is sad to say, though, we don't have a lot of the original software. But there have been some amazing projects since then. Ken Sheriff, who is out here somewhere, wrote an SH SHA 256.
You are there.
Which is really a binary floating point program for the 1401. It takes so long to mine a single, SHA 256 that it would take the lifetime of the universe to earn 1 Bitcoin on the 1401. Someone else has written a ray tracing program for the 1401, and it goes on and on. So we've the Mandelbrot set. You may have seen the picture Ken wrote. He also wrote that. The fractal generators. You see the famous one that runs on the 1401. And I think Ed has written programs to compute pi, and so you can compare them to modern machines.
Let's see. First, I would like to explain about this power of 2 program. Most of us think of a binary machine, 16-bit, 32-bit, 64-bit. Well, our power of 2 goes across the page, 132 columns. And we can do that without multiple precision. We just it's a decimal machine, we put a word mark over 132 places, and we can add 132 digits with no pain and no strain. It's an amazing machine. You have an arbitrary field length. I think I overdid it.
So,
yeah, I wanted to comment on do we get some old software that we read with our machine? And actually, Carl, you just got a huge number of cards that came in 5 boxes. And can you tell us about that?
Yeah, it was 6 boxes, but it's University of Michigan had a set of research data that they had punched back in 1970, and it only existed on punched cards. So they contacted the museum, and we agreed to take their decks and digitize it so they can take those results from research done in 1970 and begin to massage it with more current research and get value out of it. So those are the kinds of things we do in addition to just repairing broken transistors.
And you were able to read how many cards?
I didn't. It's thousands. So, it's 6 boxes packed with cards.
This brings up a question I've been meaning to ask the team, and I really haven't. It's the first time I really thought about it so much. But we talk about the 1401 as being a business machine. I was impressed when I saw Pat's demonstration on Wednesday how much experience and dedication was going into making it an accounting machine. It was a replacement for punched card equipment, et cetera. And that's what is. And so it really wasn't supposed to be so much a computer, but it ended up being one because that turned out to be a cheapest, best way to do this at the time, as I understand it. Anyway, and then at the time, which was sort of it seems strange to us today, there was a big division between scientific computing, which I tend to put the PDP-1 in, and commercial computing, which clearly the 1401 is. And I'm going to ask Steve Russell here to talk about this some, because you've been involved in the field for a while, and I'm sure you have some experience with this. And what do you think about that division? Did it make sense then? Does it make sense now? How do you think about this commercial accounting stuff, business versus scientific?
The PDP-1 and the 1401 had considerably different audiences. 1401 was a workhorse for accounting, and accounting programs of the day are kind of boring. And the PDP-1 was used for various sorts of research, not all of which was sponsored. And a lot of the times the result of the research was, well, there's a future to doing things with graphics and computers, but we need a better display and a faster computer. And that doesn't leave a trail.
Yeah, that's an extremely good point. Is the graphics display on those early machines was pretty rare.
And the PDP-1 has a light pen, which was fairly cranky when it was working, and ours isn't working well enough to is even more cranky than original. But since it was cranky, the conclusion was that they needed better pointing devices. And so we have mice now. Well, and flaky touchscreens.
So, yes, please, go ahead.
So it's sort of interesting to know that although the 1401 did lots of commercial business processing, it was also used quite often. Big as it seems, it was small compared to the big scientific machines of the time, the 7090 that you'd see in the movie Hidden Figures, for example. So a 1401, and that would do nothing more than take cards and print things out, put it on tape, so that the much more powerful 7090 wouldn't be waiting for I/O devices. So in some cases, it was tied to the scientific side, but in a support role.
Yeah, one of the fascinating differences between the two systems when you compare them is the 1401 was truly what I would call an appliance in the sense that it was really designed to move data between peripherals. And as a result, IBM was able to come out with a vast range of peripherals on the 1401. Like Ed was saying, it moves variable lengths data. A word can be arbitrarily long. Everyone today is used to 64-bit words, and in the 1401, you can add two numbers of arbitrary length with one instruction. The I/O peripherals can move data of arbitrary length in and out. So there tended to be zillions of peripherals built for the 1401. When you look at your bank check, and you look at those little funny numbers at the bottom, that came out with the 1401. Those readers were reading the bank checks through the 1401. The very first satellite transmission between America and Europe were between two 1401s via the Telstar satellite because it was easy to build a modem peripheral for the 1401, just move some bits around, right? So the bits happened to be going through Telstar. So it was a classic embedded machine. In many ways, it was much like the Xerox Alto, actually. So it's interesting that some of my guys have worked on that. The Alto was also an appliance in the sense that it had a constrained set of input and output peripherals. There's no general DMA bus. The 7090 is gigantic because it has a huge channel controller that goes with it. So when you get away from ultimate flexibility and design a simple machine, which is appliance-like, that always gives you a winner in the marketplace.
Yes.
I think, yeah. Hello? Yeah. I think that one of the important byproducts of the 1401 was card chips.
Was what, Steve?
Card chips.
Chip.
The 1401 has a wastebasket. And at Stanford, when it was being used as an offline printer for the 7090, it would fill up its wastebasket about once a week. And some of us who were using it on the week, using the 7090 on the weekend, got exasperated because we'd get the 1401 would stop because the wastebasket was full. So we took to emptying the wastebasket every week into a closet, into card boxes in a closet that wasn't used for anything else. And it turned out experimentally that after a year, there were enough card chips to fill a VW Beetle.
So I suppose we should have put them in a box and set them in Florida because that's where all the hanging chads eventually ended up. Yeah.
Okay, well, you
great
brought up a
question.
really good point. So in late 1957, Watson decreed that IBM computers would no longer be built with vacuum tubes. It was called Solid State in '58. Was the slogan. IBM was a bit behind, like they usually are. You're making lots of money with your tube computers and tube components, and so this actually struck the 1401 design team right at that moment. They were told no vacuum tubes. So how do you drive 60-volt hammers on a line printer without vacuum tubes? And so they went to this place called Delco, who was just developing transistors for spark plug firing, and they got the germanium high-powered transistors from Delco. The first 1401 actually almost burned up in the lab because a Delco transistor caught fire. Throughout the rest of the system, there are no vacuum tubes. However, if you're an insider and you come in our room and you treat us nicely, we can open up the 1402 and show you 2 vacuum tubes that are hidden inside an old piece of the 1402, which is, but they officially don't exist.
So I'd like to ask a question of Joe Frederick here. Having been involved in this restoration for the period that it took, longer than we anticipated, and we've been demonstrating it now for some time with. Anyway, I'd like if you could please tell us a little bit about the reliability or lack thereof of the machine over that period of time, and also what sort of ideas you might have as to how that machine, the PDP-1 in particular, could continue to serve the museum's needs in the future.
I think Lyle should answer this question.
Lyle, oh, thanks. Well, so that's definitely the mark of a leader, you see. It's called delegation. All right,
okay,
Lyle.
the question on system reliability. The machine has been really quite reliable. We've had some very minor problems with circuit breakers because now they're getting old. After this many years, they're finally starting to go. So we have some that a couple that we need to replace that are old. But amazingly, we've had one logic problem and one memory problem in 10 years. Which is kind of amazing, you know, when you restore a machine that's as vintage as a PDP-1 to have it be so utterly reliable. And part of that, I think, is the quality of the machine. Part of it, I think, is we were really careful when we did the restoration, and we made sure that everything was right.
Also, it was stored well for its entire life. And the 1401 crew has some bad stories about things that were not stored well.
Yeah, I think the other thing too, Steve, is the fact that in the case of the 1401, because the Connecticut machine was stored properly and did have a good environment, yet it still fails. But you have a different mechanical aspect. You have card readers, you have card punch, you have all these things that on the PDP-1 we don't have. We have a nice simple paper tape reader that is very simple mechanically. Our punch is a burpee punch, and it's super reliable. We have a terrible, terrible console typewriter, which Ken and I have unfortunately had the experience of working on. And so, yeah, basically we're more fortunate because of peripherals, primarily because the PDP-1 itself is, like I said, I find it amazingly reliable.
Well,
so I'd like to ask
a different design philosophy. DEC's design philosophy was to be cheap for DEC. And so they used paper tape instead of cards because paper tape equipment was cheaper than cards. IBM did not have that philosophy.
Well, IBM had to be consistent with what they had in Unirecord. I mean, because it was a transit.
Go ahead, Joe.
Yeah, I would like to say that one of the things that we experienced with the 1401s has to do with materials. So things like foam or rubber that lost their plasticizers just because of age. The choice of the material back in the 1950s never envisioned it being around in 2017. The transistors, in the early days of transistors, first the germanium they used was easy to contaminate. The sealing wasn't so good. We found out that when you stored one of the machines in a very wet environment, the leads on the transistor would rust out and fall off. So we had a lot of the reliability problems had to do with materials and aging more than the intrinsics of the transistor or the design failing.
So, go ahead. I'm curious about this, really.
Yeah, on the topic of rust, there was a massive industry transition in the mid-50s, right, from vacuum tubes, which were known to be unreliable, to solid state, which was supposed to be reliable. And what we learned now, 50 years later, is that, well, when they built the germanium diodes, they put iron in the leads so that the glass could adhere better to the leads. They also did the same thing in the TO5 transistor cases. So all those cases have ferrous metal in them, which rust. And so that was the big thing. We had over 130 failed SMS cards in the German system. And now that we're in a climate-controlled environment, we believe that the failure rate is now declining.
So I'd like,
Didn't the 1620 have a problem with materials in the core memory wires? I believe that's pernicious throughout
Yes.
1620s.
yeah, that's a,
Yeah, the 1620 restoration, I mean, the core memory was like all the fine wires were just corroded right off as they entered the core planes. So it was just a completely disconnected.
Some chemical they used.
I was going to ask Lyle and maybe Bob or whoever keeps the logs for these two machines. I mean, do you know about how much time the machine has been running in its restored state? You know, do you remember when
we do.
time clock was when we started the restorations compared to what it is today?
Well, on the German machine, it has the CE clock and a runtime clock, and so when the machine arrived, we knew how many hours it had been run, which basically showed it had been run for 8 years, 24 hours a day. I mean, back in the day, the 1401 system, if you were to buy it today, the system you see out there would set you back $2.5 million. A monthly rental in today's dollars would have been $100,000 a month. That was considered cheap. So they ran them 24 hours a day. And so both our 1401 from Germany and the one from Connecticut, each was run for 8 to 10 years, 24 hours a day before they were procured by individuals. And we can go back and look at the German machine to see how many hours it's added since then. But the Connecticut machine did not have a clock, as I recall.
so if I,
In terms of the PDP-1, it would be very simple to figure that out, but unfortunately I don't have the numbers in my head because we have the original log that we started online. So it's actually
yeah.
very easy to compute, but I don't know it in my head.
Yeah. I kind of had a question for you. One of the things we just talked about is when things don't work, and you as demonstrating this machine, what do you do when some things don't work?
So you haven't seen my tap dancing, have you? Yeah. So if the machine doesn't work, well, fortunately, just on a macro level, we have two machines, so we always have one that's working. But if something fails during the demo, we do our best to work around it. And one of the things that happens a lot, it's not the machine failing, it's an operator error. So if we make an operator error, we always say we like to have the most authentic demonstration possible, including operator errors, and that usually relieves some of the tension.
So usually, they write a report after every demonstration, what works, what doesn't work. And when they report something that doesn't work, usually somebody from the restoration says, well, you must have done this wrong. This must be an operator problem. But actually, the 1401 has so many mechanical parts. And it's also because the peripheral is so amazing, but there are also so many of them. We have to take care of 9 tapes, right? There's a lot of places where something could go wrong. Mm-hmm. The key punches, and they get used very often, right? But we keep it up. I mean, most of the time, it's at least one machine that's 100% up for running the demo, and it's rare that we have to skip a week. It hasn't happened often.
One of the issues we had, the German machine, basically for 4 years, it wasn't fully functional. And I know people at the museum were starting to get tired of us. When is it going to work? When is it going to work? And so on a Friday night, I'm driving around, and on my cell phone, I get a call from someone that says, my father has a 1401 in his basement. Would you be interested? And I said, what? And this was the machine in Connecticut. This family had run a small business service from the basement of their home. Not telling the neighbors. They would turn on the 12 kilowatt machine and the neighborhood lights would go down. And, it was just an amazing story. Their customers, they operated the machine until 1995. 1995. Who were the most retro trailing edge customers would do that, where they were Westchester County golf courses. You know, you go to the bar, you know, and you give them a punch card, and they must have thought it was iconic back then. But you know, it was just a bad situation. So I said, yes, let's get it. And I convinced the staff that we needed to get another one. The very week that the system from Connecticut arrived in the lab, the German system stopped failing. It's like its sibling was there, you know. It was going to get kicked out by sibling rivalry. I have to work now. I can't fail. So ever since then, except for one case when the museum lost electricity, I believe we haven't missed a single demo because we have two systems. I mean, it's been close. You know, like right now, the German machine is misbehaving. For the last 2 months, the Connecticut machine was misbehaving. So by having two, we've been able to keep demos going since 2009. I think every twice a week.
Steve, go ahead.
I'd like to note that one of the incidental maintenance efforts on the 1401 is key punches.
Is what, Steve? One of the ongoing is what?
What's your question, Steve?
One of the incidental maintenance efforts to the 1401 is fixing key punches.
Yes, the key punches.
A continuing job which was kept IBM busy back when the 1401 was new.
Yeah, the key punches and the tape decks. Yeah. And by the way, before this panel ends, I'm not going to ask anyone to raise their hands, but if you would please be interested in joining any of our ongoing restoration projects, come see me afterwards.
Yeah. So Robert, I thanks for reminding me. That's something really very important. I got involved in the museum because I came to the Vintage Computer Festival many years ago. There was Dave Babcock and his merry band of folks who were talking about and working on the 1620, and they had a little show there. And I said, gee, this looks really interesting. And boy, that's about all it took. And I think everyone else got hooked in some similar way. So museum, if you can, volunteer for some projects around here, please do. And definitely all these teams are always looking for additional great folks. So please talk to anybody here if you want to contribute in some way. Joe, I'd like to ask you to sort of summarize your thoughts so far after all these years of being part of the restoration, being part of the team, being part of the ongoing efforts here. Just what sort of overall thoughts do you have about restorations in general, the ways the museum might move forward, and how well we've succeeded in our original mission?
He's done. I'll give it back. Let's see. Well, in some respects, I think that's kind of a tough question. I mean, we would love to have more involvement in restorations. I think it's a worthy thing. It gives you an opportunity to kind of get into the head of some of the people who designed these machines and figure out why they did it the way they did, and in so doing, how to fix them sometimes. You know, it's.
I'm not answering the question, but people were talking about operators. Classically, of course, we have the software people saying it's a hardware bug, and the hardware people saying it's a software bug. Well, here we have just this fixed software of adding 2 until you're done. And so we have the problem. It's either a hardware bug or an operator error. Beg your pardon. I'm so sorry, but it's a sort of a tease. I better be quiet before I get thrown off the stage.
Yeah, Ken, I'd like your input on this, please.
So restorations and future restorations, personally, there's a lot of machines that I'm fascinated by. I would love to help restore them. At the same time, it does take a lot of effort to restore a machine, and then once it's restored, a lot of continuing effort to demonstrate the machine on a regular basis. And there's only so many people in the volunteer pool at the moment that can do this, and so if we were to take on another machine, we'd either deplete resources from a previous machine, or we have to find more people. And so getting more machines restored is a challenge because we're not really sure we can find the people to do it, I think. And convincing the museum that, yeah, we could get this machine up and going, and then there's like, yeah, but who's going to keep it running? And so It's a valid concern, and I don't know the answer yet. But definitely, if you're interested in volunteering, especially if you have some skills with repairing old computers, we'd love to talk to you.
Yeah, there's a lot of opportunities at the museum. Not to sound like an advertisement, but I mean, really, we would encourage you to think about joining the museum because we have roles like docent, demonstration. We need a lot of folks for demonstrating. That's the machines. That's just a great thing. So you don't have to be some brilliant restorer or something to join a team. You can join a team as a docent to show things off in the museum, or you can do demonstrations, or you can join the restoration team, any one of those. In terms of my personal satisfaction and value that I find I do all of those things at the museum actually, but the thing that has really helped me is I've been a vintage collector for 35 years, so I have lots and lots of machines that I've restored. But the cool thing is that when I joined the museum, I learned all the things that I did wrong when I did restorations. I learned how to restore things really properly and maintain them as artifacts and have them be really amazing machines when I finished. So I learned a lot about that, not only from the team, but also from the people in collections and the curators and the other people that you get to rub your shoulders with here in the museum. So if you want to learn more about computers or vintage computers or restoration, there's all kinds of places you can learn that stuff, as well as a great place to network. So anyway, I'll pass it on.
Thank you, Lyle. Before Robert, I just want to point out that it's 14:01 right now. This session's sort of officially over, so if other people want to go and hang out, that's fine. I just want to ask you a separate question. How did you manage to arrange it so that the museum is located at 14:01 Shoreline? As well as you give us your talk on your...
Yeah, that was
pretty impressive, actually.
That was one of the hints we had. Yeah, exactly. He's talking about the address of the museum, which is obviously an interesting coincidence. Yeah, so anyone who has the time, it is a challenge because we all have jobs and, it's hard to find time maybe to volunteer. But if I could really encourage you, we can have sessions on Saturdays. We don't just meet on Wednesdays. Meeting the team is a true firsthand experience in history. You can read books, you can read articles, but to meet the 1401 restoration team, these guys all have firsthand experience dating from the 1930s, 40s, 50s, and 60s, and they were there through the birth of the computer industry. And the stories you'll hear are just amazing and will inspire you. And then creating our time machine experience is what we want to keep doing. I mean, I hope that we can keep the machines running for another 50 or 100 years. But we need people to come join and share in that experience.
So I think what you may not realize is that you don't have to have been a trained engineer on the equipment that you're restoring. You don't even really have to be an expert in restoring computers to be of great value in a team. We have complex mechanical equipment. Somebody who's great at dealing with mechanical equipment and figuring out what's wrong with it in the gears and getting it fixed is as valuable as somebody who knows the insides of that design. I'd say the 1401 team is probably about half of them have never worked for IBM before, and the other half did. We have people who can design new systems from scratch, who are great when we have really interesting challenges, people who, just all sorts of skills that come together. So you can really contribute and join a great team of people with whatever skills you have. It's your passion and willingness to commit the time is really the valuable thing you bring.
Okay, enough recruiting now. So I just wanted to relate that I've come to look forward toward the moment when the machine will fail. When there is a failure, I say, oh yes, I'm going to learn something about the machine, right? And then you get to delve into a machine that has been engineered correctly, and the solution, the cleverness of the engineering is always amazing, and it's a delight to work on those. It's not a PC that's been put together in 6 months by another computer. So I really enjoy every time we have to delve into failure and learn more about the amazing machines.
That's really a great point. I mean, in fact, all of your comments are really great because there's so much more to it than just fixing the machines. There's so much more to it, and I think you're starting to describe the social aspect here, which was a whole lot bigger than I think anyone fully expected at first. Pat?
So on docent's side, the reward comes from seeing the reactions that the visitors have, delight, laughter, guffaws, whatever. It's all good, especially the kids. See them, see their name up in printing or see their name across the top of a card. It's really priceless. And I will recruit. We are looking for more docents. Right now we only demo 2 days a week, Wednesday at 3 and Saturdays at 11. We would do more if we had more docents, so we'd like to have that. And an offer to the group, today we've already done our formal demo, but after the demo, Paul Lawton, one of my fellow docents, and myself are going to go downstairs and be at the machine all day and have it on, so just kind of do some informal demos.
Steve? Give it a sec.
We have, when we do a demo, we typically have a room full of enthusiastic audience, and we like to do more, and we need more people to do it. Somebody needs to talk, but somebody can just sit and throw switches.
Mm-hmm. Do you think we should have more demonstrations?
What?
Do you think there ought to be more demonstrations or something like that? Do you think that would be helpful?
The only thing that we can tell wears out the machine is turning it on, and once it's on, it doesn't matter whether we run 1 demo or 5.
Mm-hmm.
And we'd like to run 5.
So and that needs
but
probably
not personally, not all in one day.
Not all in one day. That makes sense. Well, folks, this is the end of this panel. Thanks so much for coming here. Thanks so much for participating, and thank these fantastic folks.